Hi dears, so welcome back to a new video. So in this video we are going to see the physical pharmaceutics one. It's under B Pharma third semester subject. Okay, so the physical pharmaceutics one, first we will see why we have to study this subject, because first semester we already studying the pharmaceutics, right? So in the pharmaceutics, the basic dosage form, prescription, postal, the basics of pharmaceutics we are learning in the pharmaceutics. So in the second year starting, we are going to learn the physical pharmaceutics. Why we are learning? Yeah, to know about the drug in detail, such as the all characteristics of the drug, how it will affect, how their characteristics like solubility, surface tension. So the all means in the formulation development, how it will act on the body. So everything we will study in the physical pharmacy, the physics related to the our drug we are going to study in the physical pharmaceutics one. So in as we have unit 5 units. Okay, so the first unit is solubility of drugs. So we will see now the introduction of solubility of drugs. Now we will see what is solubility. Solubility means we have a solute and a solvent. Okay. So when we are taking a solvent and we will add the solute. Okay. It will be the solvent what we are taking in the beaker. For example, it may be water. You imagine solute as a sugar. Okay, so once we added the solute to the solvent, it will get dissolved under the specified temperature and pressure. Okay, to give a homogeneous solution of solvent and solute. Okay, that's what your solubility is. Solute plus solvent will dissolve under the specified temperature and pressure to give the solution. Okay, so some terms in solubility which we have to learn, that is solute, what is solute, what is solvent, and what is solution, and what is saturated solution. Okay, so first we will see what is solute. Solute means the substance which is being dissolved in the solvent, we will call it as solute. Okay, so solvent means the substance which is doing the dissolving, we will call it as solvent. Okay, the solution means after the solute and solvent will homogeneously will dissolve and will give a mixture, homogeneous mixture of solute and solvent, we will call it as solution. Okay, so this we will call it as sugar solution. Okay, so what is saturated solution? Saturated solution means we added our solute, okay, in the solvent. So a solution where the solvent has dissolved the maximum amount of solute at that temperature and pressure. That means in the particular temperature and pressure, they already means the solution is completely saturated. It got completely dissolved. Maximum amount is dissolved in the particular solvent. Okay, so if we are adding additionally any solute to it, it will be getting precipitated out. So that state we will call it as saturated solution. What is saturated solution? A solution where the solvent has dissolved the maximum amount of solute at that temperature and pressure. Any added solute will precipitate out. Okay, that condition will call as saturated solution. So I think you people are clear about solubility, what is solute, what is solvent, solution, and saturated solution. So the solute will be basically our drug. Okay, what the drug which we are taking, and the solvent may be water, alcohol, anything which we are using to dissolve our drug or solute. The solution means the final output, which final solution, homogeneous mixture which we are getting, we will call it as solution. Saturated solution means our solvent has got completely maximum, it got dissolved, and if we are additionally if we are adding the solute means it will get precipitated out. That solution will called as saturated solution. I hope you people are clear about this. Now we will see what is the importance of solubility in pharmacy. Importance in pharmacy. What is the importance of solubility in the pharmacy? As you can see, formulation development, bioavailability and absorption, therapeutic efficacy and route of administration. So in the case of formulation development, so when we are going to formulate a new formulation, we have to dissolve, right? We have to dissolve, or we have to suspend, or we had to emulsify, right? Emulsify our drug. So we had to see their solubility, capability to formulate a particular dosage form. Okay, next coming for the bioavailability and absorption. Like in the oral tablets, we will take the example of the oral tablets. So oral tablets, that first we should get dissolved or dissolution to take place in the gastrointestinal tract, right? Then it will go to the membrane and it will enter into the systematic circulation. So it's a limiting steps. If we are taking the poorly water soluble drugs means it will be difficult. So water soluble drugs means it will be little, so there also the limitations is there. So the bioavailability and absorption is important because we have to achieve the solubility, then only the faster therapeutic activity will receive. Okay, so next is therapeutic efficacy. So in the case of therapeutic efficacy, for example, as we discuss now, if the drug is poorly water soluble, okay, so we don't know how much it will have, the concentration also may vary, so we can't predict how much effective therapeutic efficacy will get or not. Okay, and comes to the route of administration. So the poorly water soluble drugs route, we can't prepare, formulate like injections, so it's also a limiting step of our solubility. Okay, so these are the four important parameters of solubility in pharmacy. Now we will see the mechanism of solubility. Okay, so how our solute and solvent is getting dissolved. Okay, in some cases why it is not getting dissolved. So what is the principle behind it? Okay, so the principle or mechanism behind it is like dissolves like. So you always have to remember like dissolves like. So dissolution process depends upon the intermolecular forces between solute-solute, solvent-solvent and solute-solvent. Okay, so that means the solubility is depends upon intermolecular forces, the forces between the solute-solute, solvent-solvent and solute-solvent. Okay, this you have to remember. So we have three points you have to remember now. The first one is the solute forces. In the case of solute forces, attractive forces holding drug molecules together. Solute, right? We had already said that will be the drug. So the attractive forces which is holding the drug molecules together. So the forces usually it will be hydrogen bond. Okay, van der Waals forces. Okay. So to break these bonds we require energy. Okay. Next one is solvent forces. So the forces between solvent molecules will called as solvent forces. Okay. So usually hydrogen bond will be in the case of water. So energy required to create a hole for the solute in the case of solvent forces. The next one is solute solvent forces. Here it's a new interaction formed between the drug and solvent. It is solute solvent forces means it's a new interaction formed between the drug and solvent. So it may be either hydration or solvation. So which the solute solvent forces which will releases the energy. So the mechanism which you have to remember is a drug dissolves when solute solvent interactions are equal to or stronger than the combined solute solute plus solvent solvent forces. So in simple you have to remember we have polar solutes and non-polar solutes, right? So polar solutes only will get dissolved in polar solvents and non-polar solutes will dissolve in the non-polar solvents. Like for example, polar solute like salt or ionic drugs, it will only will get dissolved in the case in water, that is polar solvents. In the case of non-polar solute, the non-polar solutes like lipophilic drugs and oils, okay, it will get only soluble in the non-polar solvents like hexane and oils. So the rule which you have to remember is like dissolves like. That means if the molecule is having the similar polarity means we will get the better stability. Okay, this is about the mechanism of our solubility. So in the coming lecture we will see we'll go in deep of our solubility of drugs. These are the basic things which you have to know in this unit. Okay, so thank you for watching. We will see in the next video in detail. So bye bye.